Mark is planning for retirement. He estimates that he'll want to be able to withdraw $1,000 each month for 30 years once he retires. He opens a Roth IRA and finds investments that he expects to return 4.6% interest compounded monthly. There are 3 parts to this problem, and in this video, we're going to address part A, which is how much will he need to have in the account when he retires in order to meet his goal. Now, I think this problem is confusing because there's multiple steps and multiple things involved. But let's focus right now on what's actually being asked. Mark is going to plan for retirement, and he wants to set it up so that he has an account where once he retires, he will get $1,000 each month for 30 years. This money is going to be withdrawals that he makes from his annuity. So we're going to first focus on the money that we're going to be withdrawing from an annuity. Now, which formula applies to that? Let's look in Canvas. You'll note I have a financial formula sheet. All right, let me pull that up so we can look at it. You can find it right in Canvas in your modules. And it looks something like this. Now, it's really small. Hopefully you can see these things, but we're particularly going to zone in because we are looking to be making withdrawals from an annuity, and we call that a payout annuity. So we're going to be looking at the payout annuity where we're making withdrawals. And in that payout annuity, there are 2 formulas. 1 is total amount, and 2 is amount of each withdrawal. We specifically are looking for the amount in our account in order to be able to make those withdrawals. So the formula that we are going to zone in on is this one right here. We want to know what is the total amount in our account to make a certain number of withdrawals. So I'm going to copy that and put that into our problem. So let's recall now. Our problem is we want to determine how much we're going to need in our account when Mark retires in order to meet his goal. And our formula, copied over from that worksheet or from that formula sheet, says as follows, that P sub 0, or the amount in our retirement account, will be equal to D, which is our scheduled withdrawal, times the quantity of 1 minus 1 plus R over K raised to the minus NK all over R over K. And in this formula, D is our scheduled withdrawal, R is our interest rate, K is the number of compounds per year, or also the number of withdrawals per year, and N is the number of years that we're going to be making our withdrawals. Let's now take the information in our problem and put it into that formula. We begin by identifying what it is we're looking for. So in part A, we're looking for how much will Mark need in his account when he retires. Well, that in our formula is P sub 0. That's the amount in the account that we're going to be withdrawing from. D, that's going to be the amount of our withdrawals. So P sub 0 is unknown, but D is known. Our amount of withdrawals is $1,000 each month. So D is actually going to be 1,000. R is our interest rate, and our interest rate is 4.6%. And if we convert that into a decimal, that'll be 0.046. K, our number of compounds per year, is also our number of withdrawals per year. And we are withdrawing $1,000 each month. So that means there's going to be 12 withdrawals a year, so K is 12. If we were withdrawing each quarter, then K would be 4. And finally, N. N is our number of years that we'll be making those withdrawals. And the problem says that Mark wants to withdraw $1,000 each month for 30 years. And so 30 is our number N. One other thing, if you note in the formula, the exponent is minus N times K. So sometimes I actually like to go ahead and take N times K and put that right here in our information. N times K is very quick to get. We simply take 30 and we're going to multiply that times 12. And 30 times 12 is 360. I now take all of this information and plug it into our formula. This tells us that P sub 0 equals D, or 1,000, times the quantity of 1 minus quantity 1 plus R, which is 0.046, over K, which is 12, raised to the minus NK, or minus 360. All of that gets divided by R over K, or 0.046 divided by 12. Now this is quite a big, large expression, and you know my favorite friend is Desmos. So I'm going to take this expression and type it just like this into our Desmos calculator, and that's going to give us the value that we want in our account in order to make these withdrawals. So let's head over to Desmos and let's type this in. Now when we type it into Desmos, you want it to look exactly alike, and so I've taken a screenshot straight from Desmos. I made my expression match that expression I've written down. And when you type that into Desmos and you get your answer, you should get the following. You should get that value for P sub 0 is 195,067.002, or if we like, that's $195,067, and rounding to the nearest cent, 00 cents. So we can say that the money that Mark needs in his account in order to meet his goal is $195,067. And that completes part A. In the next video, we'll go ahead and look at how to solve part B.